Hello and welcome to our recorded lecture on the Earth's atmosphere. Today we're going to talk about 3 or 4 different things. The balance of the Earth's atmosphere. We're going to talk about heat and the atmosphere. We'll touch on we may touch on local temperature variations, and then we'll round out with the human's impact on the atmosphere. So the Earth's atmosphere is mainly nitrogen and oxygen. There are small amounts of other gases and dust particles in the atmosphere. Some of the other gases in the atmosphere include water vapor, and water vapor is a really important one because without the presence of liquid water, we would not be able to survive. The amounts of gases in the atmosphere can change slightly, but for the most part, the composition of the atmosphere remains fairly constant. The components and elements in the atmosphere can move through and interchange, such as, water vapor is what is present as in the atmosphere, and in the water cycle that can then also change to liquid water and or frozen water. Carbon dioxide can also move through the atmosphere and through the carbon cycle, and the nitrogen cycle also can cause elements to move through the different systems on Earth, though for the most part the concentrations of everything are fairly consistent. Occasionally, there are local events that can change the composition of the atmosphere, and one of those would be either if there were volcanic eruptions, that could definitely have a negative impact on the atmosphere in sending large amounts of particulates into the atmosphere and gases. You could also have, in terms of local events, there are, and we'll touch on this when we talk about the human influence on the atmosphere, but with other common pollutants that can negatively impact the atmosphere. There are 3 methods or ways that heat moves through the atmosphere. And we talk about heat because the Earth is warmed mainly through radiation coming from the sun. That's where the initial amount of heat comes from. And then once sort of in the atmosphere, heat can move through by means of convection as well as conduction. And we'll look at how the heat flows and the energy flows through in the next slide. But right now, I want to focus for just a moment on the different layers of the atmosphere. If you look at the graph or the diagram on the right-hand side, we can see that on the x-axis is temperature, colder being to the left, warmer being to the right. And on the y-axis, we have our height above ground, or our elevation. The different zones or layers in the atmosphere are divided up based on what the temperature changes in that layer, what the pattern of temperature changes is for an individual layer. In the troposphere, which is the layer closest to the Earth's surface, your temperature decreases as you increase in elevation. The top of the mountain is colder than the bottom of the mountain, which is why you can have snow at the top of mountains and not at the base of the mountains. Moving after the troposphere, the next layer of the atmosphere is called the stratosphere. The stratosphere is unique because the stratosphere is the layer of the atmosphere where temperature increases. And it's increasing in that layer because we have presence of ozone. Ozone is a molecule that is naturally occurring in the atmosphere, and it absorbs incoming radiation from the sun. Because it absorbs the radiation, it then traps absorbing radiation increases the heat in that layer. Above the stratosphere, we have what is referred to as the mesosphere. Right? And the mesosphere is our coldest layer of the atmosphere. And lastly, we have the thermosphere. The thermosphere is sometimes broken into two different layers, one named the ionosphere, and the furthest most layer named the exosphere. When we go and look at how the heat moves through how the heat moves through the Earth's atmosphere and in and out, we have to introduce a few new terms. One of those terms is the phrase insolation, and it's spelled with an O, insolation, and it is an abbreviation for incoming solar radiation. So that's all the heat that's coming in from the sun. As that heat enters the Earth's atmosphere, there are a couple of the 100 units that move through. Some of it is absorbed. Approximately 51% is absorbed at the Earth's surface. Some of it is automatically reflected back into space, never even comes really into the Earth's atmosphere. And then there is some that is absorbed by the atmosphere, mostly in clouds, and that would be where, absorbed, some of that is in the ozone layer. So the different gases in the atmosphere actually absorb some of it. And if you look at that, so on the left-hand side, that's what's coming in. We move over to the right-hand side and we look at how does some of that heat get back up into space, or what happens to it. Some heat transfers to the atmosphere through the process of evaporation. Some heat, 15 units, radiate from the surface to the atmosphere. And conduction and convection are a minor way that heat is transmitted back to and out of the atmosphere. 6 units go directly back to space, being radiated from the Earth's surface. So we've got, this breakdown and looking at how, whether it is through the process of radiation, which is how we receive energy from the sun, and then energy from the Earth can either radiate back to space or move back into the atmosphere through the processes of conduction or convection. We'll spend the last few minutes looking at how humans impact the atmosphere. Human activities can produce pollutants that are released into the air and affect the atmosphere. Some of our common pollutants are carbon monoxide, nitrogen dioxide, and sulfur dioxide. And we'll take just a moment to look at what some of the major sources and effects are of those pollutants. Carbon monoxide is predominantly given off through automobile exhaust. And some of the negative consequences of carbon monoxide is that it can reduce the delivery of oxygen to body tissues, and it can impair your vision and your reflexes. Nitrogen dioxide, sulfur dioxide, and actually also carbon dioxide are, even though, and carbon dioxide is not listed here, but they are produced through the burning of fossil fuels in power plants. They predominantly, nitrogen dioxide is also used or is also expelled with automobile exhaust, whereas sulfur dioxide is a byproduct of oil refineries, paper mill processing plants, as well as naturally through volcanic eruptions. Though they both can irritate very much the either respiratory and or lung system, it can contribute to acid rain, as well as being linked to lowering your abilities to fight or resist respiratory infections. Other pollutants that are common, particulates. This would be dust, smoke, soot, ash. These also produce and contribute to respiratory issues, right? And those particulates are, again, released from factories, paper mills, oil refineries, power plants, and then again naturally through volcanoes. Lead is another air pollutant that is very dangerous to the nervous and digestive systems. And lead is produced from smelters, and a smelter is a kind of like a plant or a factory. It's an industry that chemically separates heavy metals like lead, zinc, aluminum from their during their or by the process of you take the minerals and then you chemically separate them. And lastly, of common pollutants, we have ozone. Right? Again, ozone is an important gas in the atmosphere because it does protect humans from ultraviolet radiation. However, too much ozone, especially when it's considered to be what's called ground level ozone, is when it reacts with nitrogen oxides and hydrocarbons, and that creates stuff like what we call as smog. So that was just a brief introduction of the layers of the atmosphere, as well as some of the common air pollutants. That's it for today.